We're recording now.
All right.
So a manometer with mercury, which is density 13.6 grams per cubic centimeter.
Has one end attached to a pressurized vessel and the other end open to the atmosphere.
So
and
it's like
that level is lower than the other. Yeah. There you go.
All right. And so this is atmospheric.
And the height between those two is 15 centimeters.
So this distance is 15 centimeters.
Right. What is the pressure difference between the inside and the outside of the vessel? And that's where it cuts off at.
So this is a nice example of Bernoulli's principle, so we can just apply that if we want, since you were asking me about it, right? So it says, so let me just, for the people online, so I have a manometer. It's got mercury in it. The height difference between the two sides is 15 centimeters. And so we'll call this one H1 and H2, right? And we'll call this out here P1 and P2, right? And we want to know what is delta P equals P2 minus P1, right? And Bernoulli's principle is, what is Bernoulli's principle? Anyone tell me what it is? It's good to know what the principle is before you're going to learn how to use it.
Is it negative P plus 1/2 squared? So I have it written down.
Hurry up.
Hello.
We're looking for Bernoulli's principle. Do you know what Bernoulli's principle is? Just
Do I know what Bernoulli's principle is?
hot off the presses.
I had it like, what about it?
I just want to know what it is.
Oh,
What is it?
something about.
From the LP. That's not bad.
Something about rho.
Yeah, you're on it.
You're talking about P equals P naught plus rho GH?
Yeah,
Well,
that's
it's
fine.
close.
like it's how you derive it. P1 plus 1/2 rho V1 squared plus rho G1 equal to P2 plus 1/2 rho V2 squared plus
Look
rho
at you.
G1.
The pressure plus 1/2 rho v squared plus rho GH. Anywhere in the fluid, pick any 2 points and evaluate that, and it's the same. That's Bernoulli's principle. And so we can just evaluate that at the tops of these two surfaces. Right? We can evaluate pressure plus 1/2 rho v squared plus rho GH here, and pressure plus 1/2 rho v squared plus rho GH here, and we get.
Wait, that's an H?
I call these Y's. Does that bother you?
Okay, now that I know what it is.
Yeah, this is just the generic formula.
Okay.
So we're going to plug in H1 and H2 for that, right? So what are the velocities? You guys on Zoom can answer too. So what's the velocity of the mercury at the top here and at the top here?
0?
Yes. It's just sitting there.
Yeah.
So in this problem, I can just drop out these two guys. It's a static problem. And now I have, I'm looking for P2 minus P1, right? So P2 minus P1 equals rho G Y1 minus rho G Y2. That is to say, I pull this guy over to this side and push that guy over this side. This is the thing I'm after, right? And so I get delta P is equal to rho G times H1 minus H2. Sorry. Which says that P1 is larger than P2. And so this number will come out negative, right? And you can kind of tell that P1 is larger than P2 because P1 is pushing down hard enough to raise the fluid on the other side. And so here I would say this is 13.66 grams per centimeter cubed, which is times 10 meters per second squared times, and if you want to say, you say minus 15 centimeters. But I would probably convert all that into meters, right? And so 13.6 grams per centimeter cubed equals 13,600 kilograms per cubic meter. And so this would be delta P equals 13,600 kilograms per cubic meter times 10 meters per second squared times 0.15 meters. If I'm just looking for the magnitude, or I put the minus sign if I want a difference. But if they're just asking for the difference, you probably just want the magnitude out of the top of the minus sign. So I don't know what that comes out to.
20,000.
Say again?
20,000.
Okay, that sounds about right.
20,400.
Okay.
The answer you're looking for is 20,000.
So that's a manometer problem with Bernoulli's principle. What else?
Is that going to be given to us on the sheet?
Bernoulli's principle?
Yes, it is. Okay, just want to make sure. I just have to remember about the velocity. Zero, that way cancel that out.
If the problem's static.
So usually isn't a manometer problem static.
Yes, you can light. The light is enough. Let's switch it enough.
Yeah. Is this the one you're gonna give us the test on that you're letting me use?
Yeah.
Yes, it is.
It's in the file section.
Yeah.
Okay.
What else? Anybody on Zoom want to ask me a question? What are people on Zoom? I just imagine they're laying in their bed, right? With their covers all the way up over them and just holding the phone there.
Yeah.
And it's like,
I'm not gonna lie, that has been me.
that's how I would be.
I'll have my laptop open and then I'll just be.
That's how I would be. So,
Once or twice, not all.
I have one.
all right.
I was doing it earlier and I was a little off, so I'm actually on this one. This ball of mass is 90 kilograms standing on ice covered lake. Oh, wait. I think I know why I was off, but I want to make sure.
Okay. All right.
So, mass 90 kilograms, ball, sitting on ice. And his shoes are 300 centimeters squared area. What is the pressure in Pascal to the ball? I guess on the lake, that's all, that's what it's on.
Yeah, what's the pressure on the ice? So it's the total area of both shoes?
Yeah, it just says that Bob shoes are 307 meters in area.
Okay, so it's still there. Right, so how do you figure that out? What's the definition of pressure?
Force or area.
Yeah, so pressure is equal to force divided by area. What's the force that Bob's shoes are supporting?
Gravity.
Yeah. mg divided by the area, which is 90 kilograms times 10 meters per second squared, divided by, where you made your mistake.
Yeah, here's the thing, I didn't know if it was gonna be with 2 or not.
Oh, you know, there were 2 shoes and I would put 370 there.
It's 300.
Oh, it's 300?
Yeah.
Did I just mishear you or did
I think so.
Why is it that when I wear a mask, I hear worse? That's what I was.
Then, like, read their mouth. Yeah. Yeah, some people read lips to like hear better,
Oh, it's true.
so you can't.
So,
You know what's worse? It's like somebody asked me a question in class and I can't see
You can't
anybody's
see any
listening to me.
movement. Yeah, you're not
And so I'm
going
like
crazy.
frantically looking around, trying to see if eye contact is gonna help me.
I get a microphone.
So what do I have to do with this? Convert, yeah. And so I have to multiply this by, I want it in meters squared. So meters squared, meters over 100 centimeters squared, right? And so I'm dividing that by 10,000. So is this 30,000?
yes.
So when we see a problem like that, it's just gonna be for one shoe. It was just.
So yeah, if I ask a question like that that's ambiguous on the test, hopefully I won't. It's just asking me.
Okay.
Say, hey, is that for both shoes or for one shoe?
So you said is that 300 times 100 or divided by 100?
So
Because
this is 300
right,
and that's 900.
right.
So that gives me 3. And this is multiplying it by 10,000. Right? Because I'm going to have 1 over 100 centimeters, quantity squared is 10,000. And so 3 times 10,000 is 30,000. Did I do something crazy? I'm not above making math errors.
No, it's for the conversion.
Oh,
No, it's
Do we need to know how many atmospheres, how many pascals is in an atmosphere?
is that not on the equation sheet?
I don't have any stuff.
what is
It's
it?
in the files section for crying out loud.
How many pascals?
But, okay, if you any kind of unit conversion, you ask me, but this has been there for like weeks.
Yeah,
So,
I looked at
1
it.
atmosphere equals 1.01 times 10 to the 20 pascals equals 760 millimeters of mercury equals 14.7 Kelvin per square inch. That's on there. But let me just say that if you have any unit conversion questions on an exam, you can just raise your hand and ask me, and I might just embarrass you just a little bit. But I will tell you, I don't want you to get a problem with it because there's a unit conversion issue that you have.
Where is that? Is that on the first page? It's just some pride for some extra points.
Oh, now you're going to tell me it's not on there. Hopefully, this should have saved. That was embarrassing.
Did you see that?
What's up?
It's
Oh, you can check it out. Might be different.
Because I feel like I looked at this help sheet, I printed it out, and I highlighted stuff.
I don't see it.
Where did you get that?
I printed it out.
Trail.
What? You need extra help?
That's on you.
That's
Trail.
It is. I don't know there. So it's on that one, not on this
I just see that.
one. And you
from
did,
lab.
did you just get this off of the website?
Yeah.
Off the
your
file
file.
section? Watch it. Thank you for bringing it up.
I know that you.
All right, no.
Can I like
I know what
find
that is, but
Yeah.
grab my stuff?
He's doing it for.
You can do whatever you want to do.
Okay, I'll do that.
What else?
Dr. Trill,
Yes.
go over the frequencies of waves, like in the tube that's closed at one end and open on the other end?
So do you mean like this thing?
Yeah, and then there's like all the different frequencies as there's more waves.
So this one is, the next one is like this, and it's like this, and the nth one is 2n minus 1 times v over 4l.
So that's the
Or it's equal to 2n minus 1 times f1. I think that equation is on your sheet, actually. Am I answering the question you asked me?
Yeah. Yeah. Is there like I don't have like an example problem with me. Do you? I don't know if you could do like
I don't have any. You're gonna have to, I think there's something on in the learning catalytics. If they're not just running off the side of the screen, I gather that happened on a bunch of them.
Okay, yeah, but like since this entire thing is squared, because you have to square this in order to get this, so you would really be, it would really be 300 divided by. So then that would be like say 90 times 10 divided by, what was it?
0.03.
0.03. So then I'll put that in.
Yeah, I got it.
Yeah, with the whole like
That's
area,
the step that freaking killing me.
with the whole area or squaring and cubing instead of just having to you just gotta make sure that every time that you see a conversion, that you also make sure that the exponent.
Okay, Dr. Trail. Did you do the problem where it's the first harmonic for a particular guitar string is 250 hertz? And then what is the frequency of the third harmonic?
Wait. So F1, so for a particular guitar string, F1 is equal to 250 hertz.
Yes.
All right.
And then it's asking what the frequency is of the third harmonic.
All right. So the formula for harmonics on a guitar string is Fn is equal to N F1. So what's the third one going to be?
Yeah, that's what I don't really understand. I don't understand how you like.
If I put a 3 here, what's this number?
So 3 times 250.
Yes, that's it.
Okay. Thank you.
Oh, you bet.
I have one kind of like that too, honestly.
All right.
It's a little bit more.
This is why we're here. All right, I'm gonna be back in 1 second. I just have to check to see if I please set this thing up.
That's 10 bonus points.
Where'd you go?
I think she won.
She went to go. She was here just to get her 4 o'clock and over with. I respect it. I mean, he's just my favorite thing about it is the way that did he tell you to go lower? I was like, no. My guy doesn't go that low. And he realizes that if you get too low, I was like he does realize that it's not good.
All right, I'm back. Ask me another question.
Let's try a pipe that is closed at one end, has a first harmonic of frequency of 250 hertz.
pipe that's closed at one end. So that's what its first harmonic is. F1 is equal to what?
Closed pipe. Is it 2n minus 1?
Wait. So I don't have your whole story yet.
Oh, I'm sorry. 250 hertz. Sorry.
250 hertz.
Yeah.
And so what's the question?
What are the frequencies of the first two overtones?
Okay. So F2 and F3.
The oscillation.
That's not right.
Right, the next two harmonics, that's what they mean by that, right? And so how are we gonna figure that out? I think you're gonna say it just a second
I
ago.
hope I am. The 2n minus 1 times velocity. over
Yes, it
4L.
is. So the nth harmonic is equal to 2n minus 1 times the first one. Scott, what does that formula look like? Let's see. Right. For the first formula, what does it look like? So this is a formula, right?
Yeah.
So for n equals 2, what's the value? Yeah, it's F2 is equal to 2 times 2 minus 1. F1 is equal to 3 F1 is 750 hertz. What's the next harmonic?
1250. So here's my question on the help sheet. So it gives us the 2n minus 1 parentheses and then times velocity over 4L, right? But you switch it over to F1.
F1 is V over 4L for F close to one end.
So, but the thing is on this, it shows Fn equals n times velocity over 2L.
That's for open and closed ends.
The first two equations is for open.
So where's the one for closed?
This second two.
That one says wavelength though.
Yeah, there's a wavelength and frequency. You just convert it. The first two. These two are for open and closed times. These two are for closed times.
I mean, that's some memorization on my part. I guess I have to know.
You
Man, I
have to,
wish it
like,
would just say it on there.
you have to do some work.
Thank you for saying that. You said it perfectly.
Some of those learning how to lit it questions online, were like,
They were just telling me that. I can't fix that by tonight. I'll try to pay more attention to that when I make those files. It is such an ordeal to get the thing to print answers. It'll print the questions, but I can't print the answers. And so I finally found a way to get to print the answers, and then it cuts the screen off. I don't know what to do about that. I'll mess with it, but I'm not going to be able to fix it. I don't think.
So do you print it off like directly from?
I do. That's like the world's worst website. It's shockingly bad. It was great 5 years ago when it was like the only one that was around, or it was brand new, and now I'm just like.
It's gonna get better with more competition.
You would think. I'm working on that, but it won't happen this semester. I wish we just had one in house. It doesn't have to be very complicated. Somebody could write one, some computer program. I could write one if I just had a little time. It would be free.
okay, I have one.
All right,
A cube of side L has density P. Okay.
Rho.
If the cube is compressed so that each side has length of L over 2, what is the new density of the cube?
All right. That's a good one. So what is it?
8 times density.
Yeah.
Oh,
Oh,
I don't know how to do it.
so So I've taken a cube. Oh, so let's just draw a picture, right? Here's my cube. Are we good on that one? That's my cube, right? And now, so it's every side is length L, right? And now I've compressed it so that its volume is 1/8, right? In other words, this side of it is now, instead of being this wide, it's only half that wide, right? Same thing with this side, same thing with this side, and this side, and this side, and so on. So that 8 of these you agree with me? 8 of them fit in there. And so that means its volume is 8 times smaller, but it has the same mass. If its volume is 8 times smaller, its density is 8 times bigger, right? If you wanted to, you could say density 1 is equal to m over L cubed. Sorry, lowercase l, right? Density 2 is equal to mass divided by L over 2 cubed, because it's side times side times side, right? But this is just m over L cubed divided by 8, which is 8 times m over L cubed, which is equal to 8 times rho 1.
Because it'd be 1/8, so it would just, like, two.
You invert when you multiply, right? And so I would invert and multiply. It puts the 8 in the numerator.
It's because it's divided by 8. You know what I mean? Like it's 1/8.
Oh, okay.
Yeah.
I don't know how else to say it. Which one? What else?
I think I got one.
Come on.
What is the intensity of a sound that has a sound level of 65?
All right. What's our generic formula for sound level? Anybody?
NDB.
Thank you. What's this I0 thing? It's a threshold of human hearing, right? And so we just pick it as 10 to the minus 12 watts per square meter, because that's the lowest intensity you guys can hear. It's way lower than the lowest I can hear, but we just assume everybody's the same, right? And so now I have my beta and I'm looking for I, right? And so I've got to untangle this thing somehow. And so, Christian, how do I do that?
Divide by 10 dB first.
So I'm not going to plug in any numbers because he gets mad when I do that. So 10 decibels, right, is equal to the log of I over I0. Then what do I do?
Take the inverse function of log.
Which is what?
10 to.
So I raise each side to the 10 to the this. If that thing equals that thing, then 10 to the this side equals 10 to the that side. And the reason I do that is, as Christian just said, 10 to the log, 10 and log are inverse functions, or exponent of 10 and log are inverse functions. And so this gives me 10 to the beta over 10 decibels is equal to I over I0. Those two just undo each other. And so this gives me I is equal to I0 times 10 to the beta over 10 decibels, which is I0 times 10 to the 65 decibels over 10 decibels, which is I naught times so 10 to the 6.5. So this is 10 to the minus 12 watts per square meter. 10 to the 6.5. If you're clever, you can kind of do these things. It's 10 to the 6 times 10 to the square root times square root of 10. And so this is 10 to the 6 times the square root of 10, which is equal to like 3.16 times 10 to the minus 6 watts per square meter. And so that should be approximately your intensity for that one. Follow that?
Yeah.
Where were you lost?
The algebraic part.
Yes.
Well, all right, so let's go through a little slower. So this is where we start, right? And that's just the equation you get, right? And I just wanted to recognize that I naught as 10 to the minus 12 is just something we use for human hearing. It's just how human ear works, right? And so I'm trying to get this guy. And so untangling him is kind of tricky. And so I just want to get him by himself somehow. And so I divide out the 10 decibels, and now I'm left with a log function. And the only way to undo a function is to apply an inverse function. If this is a sine of something, I'd have to take the inverse sign. Well, the way invert a log is you take the exponent of it, is you take 10 to the. And so, in other words, if you go all the way back to how logs work, log base b of a is equal to x means b to the x equals a, right? And so when I raise an exponent to a log, the inverse function of this is just the exponent. And so if I take the log of both sides, so log base 10 of 10 to the third is just 3. It's just x. Hopefully you can see that they're inverse functions. So this is saying, this is saying 10 to what power is equal to 10 to the x, right? If I say log base b of b to the x is equal to question mark, what I'm saying is b to what power is equal to b to the x? It's just x. You follow me? This is how log works. This tells you that log and exponent are the inverse functions of each other. Because this just undoes what the b to the x does. And so b to the log base b of x is equal to x for the inverse reasons. And so if I want to convert this log function, if I want to get rid of this log function, I have to take 10 to both sides. 10 to the beta over 10 decibels is equal to 10 to the log of I over I naught. And that just becomes I over I naught. And now you can solve for I by cross multiplying and substituting. I know you guys have all seen logs, and all I can say is it's hard for everybody because you see them rarely and they're kind of unfamiliar, I would say. But you've just got to kind of wrestle with them a little bit. They're super useful in lots of areas of science, engineering, math. All right, what else? Say again?
Was there maybe another problem that was similar to that that we could just run through real quick so we get like?
Pick another one. Somebody pick another one. Someone's looking for another problem on sound level. So if anybody online wants to toss one out.
I have one. What is the sound level of a sound that is 5 times as intense as an 80 decibels?
Okay.
Oh, no, there was definitely not. Yeah, I'm just worried about it.
All right. So what's our standard sound level equation?
Beta equals 10 dB above 10 dB over I naught.
So now we're asking for two different sounds. So I'm going to say beta 1 is equal to I1, 10 decibels log of I1 over I naught. And I'm going to say, look, beta 2 is equal to 10 decibels times the log of I2 over I naught. But I'm going to say, look, I2 is equal to 5 I1. I'm saying, what is the sound level of a sound that is 5 times as intense as an 80 decibel sound? So here's my 80 decibel sound. Right? That's my first one. And I'm saying, look, this guy is 5 times as intense. What's his sound level? So any thoughts? For sure you could do that, right? You could just do what we did just a minute ago. Invert this thing and find I1, and then plug 5 times that back in and solve the problem. Right? You could also say this. You could say, look, beta 2 is 10 decibels times the log of 5 times I1 over I naught, right? Because that's what the definition of this thing is, right? And then you can recognize that log of A times B is equal to log of A plus the log of B. And so I can say this is equal to 10 decibels times the log of 5 plus the log of I1 over I naught, which is 10 decibels times the log of 5 plus 10 decibels times the log of I1 over I naught. What is the log of 5? Like 0.4 or something like that? 0.69? And so this is equal to 6.9 decibels plus 80 decibels, because we just said that 10 decibels times the log of I1 over I naught is 80 decibels. And so this is 87 decibels. How do you feel about that, Ella? Just kidding. I know. She asked it. No, you read it, but she was asking for one. That's fine. So there's just a little log math on these, you know, you just have to kind of. There's usually more than one way to solve them, but the nice thing about that, by the way, is that once you figure this out, notice it didn't matter. This piece, this 6.9, didn't matter what the original intensity was. So any intensity that's 5 times as intense as another intensity just increases the sound level by 7 decibels. So if it's 5 times as intense as a 37 decibel sound, that means it's 37 plus 7, which is 44 decibels. Right? All you're doing is adding this each time.
So what if it said like 10 times? Would you say 14?
It would be 10 decibels times the log of 10. It would just be 10 decibels higher.
I don't know if you already did it, but it's a manometer carrying mercury density 13.6 grams per centimeter cube, has one end attached to a pressurized vessel and the other open to the atmosphere. Between the two sides of the manometer is 15 centimeters.
So we did do that one already, but it's recorded. So you can just take a look at it later if you want to.
So if you just convert that grams per centimeter cube to kilograms.
Yeah. Yeah.
And then row pH.
Yeah.
And also the centimeters too.
Huh?
The 15 centimeters.
Okay. Centimeters.
Yeah, it's exactly what you do.
Except the one thing that got me on that one is the converting it to meters though. Like, tell me how you would convert that to meters. Like if you were to set up the problem. I don't know if you even tried it yet. But
You would have to cube it, right? Is that what you're talking about?
Yeah.
yeah. I was making sure you did that. That's the one thing I talked about. Anyway. Um,
Oh.
Question with a 1 kilogram copper, the capacity is 390 joule per kilogram Kelvin cube at 0 degrees Celsius placed in a 1 kilogram of water, which has this capacity at 50 degrees Celsius, and an insulated container degrees Celsius of the copper and water when they are equilibrium. So I guess it's cut out, so that's why it sounds weird. But it's trying to find the temperature at the T final.
Right. And so,
So my question is though on that, before we like dig into it, is that I would look back at my notes, and what we have to use the equation wise is ginormous, and I didn't know if that is somewhere even close on the help sheet. So like what it's supposed to be, I think it's like mass times the material, and then capacity times it, stuff like that.
so the Q water plus Q copper equal to 0 because they're insulated. One gains heat, one loses heat, right? And so this is mass of water times C for water times delta T for water plus mass of copper, C for copper, delta T for copper equals 0. And then you just solve. This is delta T for water is equal to T final minus T water initial. Delta T for copper is equal to T final because they both have the same final temperature because they're in equilibrium minus T copper initial. Take this guy and plug it into that one. Take this guy and plug it into that one.
I got it. I'm just saying like, would that be on the help sheet anyway?
Well, what be on the help sheet?
That.
This is on the help sheet. MC delta T, right? Q equals MC delta T should be on that help sheet. You're just applying it.
C is the given, the specific heat capacity. That's given.
So I put a bunch of them on the sheet, and usually what I do is I just pick stuff that's on the sheet for the problems. If I don't, I'll stick it inside the problem somewhere. Try to just use them off that sheet so I'm not overloading you guys with problem data. That confuses some people though, because they forget to look on the sheet and they think they should have known what the capacity of copper was until they finally asked me.
So we should have that given.
Yep.
In either the problem or on the
Yep.
sheet.
I don't think so. Unless I do.
Can we use that to find the total heat required to like heat something from a temperature to another one?
Yeah. Unless it changes phase in between, and you've got to use those phase change equations.
Are those on there also?
Can you explain the 1 kilogram of aluminum, 1 kilogram of lead? How do you know which one's greater?
Oh, which has a greater density?
What?
Which has a greater density, lead or aluminum? Lead.
Right?
Say again?
What?
Yeah. So which is bigger? Which is bigger?
Aluminum,
Same mass.
Same mass. Which is bigger?
the aluminum.
How do you know the aluminum's bigger?
Volume.
But if it's more dense, does that have a greater
So,
volume?
so if I have two things that have the same mass, but one of them is more dense, which one is bigger? The one that's,
Not as dense.
yes. So the aluminum is bigger. Yes? Okay. So which one displaces more water?
The heavier
What?
No, the aluminum does.
displacement.
So when I stick them down in the water, how much? So let's say I take this battery and I submerge it in water. How much water does it displace?
None.
All right, none.
Because it goes all the way down, right?
If I stick this in water, how much water does it push out of the way?
All
All of what?
of all the water.
So if I drop this in the ocean, all the ocean water leaves. How much water does this displace?
Its weight. Oh, I mean, the size
Come
of
on,
the
folks, somebody
object.
tell me, if I put this in water, all you Zoom people, get up off the couch, think for a second. If I drop this battery down in water, what does this battery displace in water? I'm so disappointed.
Is it the size of the battery?
What do you mean by size?
Oh. The weight?
I look, thought it was the weight, honestly. I have to store that somewhere in there.
The weight?
But if I drop this down in this cup right here, how much water is going to get pushed out of the way?
The area?
Close, not the area,
The volume.
the volume. This pushes out of the way enough water that takes up the space of the battery, so there's room for the battery. If you're a very crowded room and you're going to push your way in, you have to make enough room for your volume, not your weight. I mean, they're not unrelated. So, let me get back to the original question. Which one has a greater buoyant force? The aluminum or the lead? Why?
Because it displaces more water.
Yes. The buoyant force by Archimedes' principle is equal to the weight of the water that was displaced. If it displaces more water, it's got a greater buoyant force. All right.
Please ask a conceptual question on the exam so I can feel better about myself.
you know, people are just both ways on conceptual questions. I'll have people come to say, I hate conceptual
I
questions.
love it because it, like, I feel like I have one.
Come on.
Okay. After a party, the host pours the remnants of several bottles of wine into a jug. He then inserts a cork with a 1.75 centimeter diameter into the jug, placing it in direct contact with the wine. He is amazed when he pounds the cork into place that the bottom of the jug with a 14.5 centimeter diameter breaks away. Find the force in newtons that the liquid exerts on the bottom of the bottle when the host is pounding the cork with 140 newton force. That was a lot.
Yeah, that's a lot. So that's Pascal's principle. There are only a few ways to have Pascal's principle as an example. And so the cork wine goes back like, I don't know, 50 years. And I always feel like, what kind of a drunk guy is this that he pours all these wines into it? Anyway,
I should have just said the one.
so here's the idea. I have a bottle here. This says area 1, and this is area 2, right? But the pressure in these two is the same. And so if he's saying he has, how much was the force at the top? Was it 140 newtons?
Yeah.
So you can use 140 newtons divided by the area of the cork, and that'll give you the pressure, and it's the same pressure at the bottom. This is F1, and then F2 equals the pressure times area 2, and so you can call this F1 over area 1 times area 2. That's the force on the bottom of the cork. And so it's the force times the ratio of the two areas is the force you're getting at the bottom. It's the force at the top times the ratio of the areas. I said that in class one time. It was just a beer bottle or something. I said, you can just, if you fill them all the way up to the top, you can just hit the top of it and break the bottom off. And somebody came in the next day and said, by golly, you're right. I didn't mean for you to try it. Fortunately, everything's made out of plastic nowadays.
Yeah, I'll try.
That's too good. Yeah. I was like, oh, that's it.
You might, no, because we're supposed to set up for how to do this. Did you get the text up? Yeah.
Is this like track talk?
Yes.
Yeah.
Cool. Is Jen still the coach?
Yes.
Awesome.
Hey, don't worry. No, honestly, don't worry about it. Just text me if James says anything, then don't worry about it. And I'll tell you whatever she says.
Does she run with you guys? I bet she does. Does she run with you guys?
Yeah. Well, sometimes she runs across, or
She runs
like,
the cross.
Cross country.
I'm not a cross.
Oh.
yeah. I was like, 'cause she definitely like ran with us, and I'm like.
Yeah, you practiced with them, but
I practiced with them a little bit. Technically, I should be practicing with them now. We're just gonna see what happens. I'm so scared for the
Oh, dang, I have a thing for Duffel to sign too. I haven't printed it out yet. Start dates of absence.
What's that?
Start leave dates, like our dates of absence. Gotta do that.
I'm a rubber stamp on those babies.
Can we make it a deal? Like, if the sports team like makes some sort of win. I know that my Cowboys like lost, so.
Say that again?
Extra 10 points to Jack's team.
Extra 10 points
For
if a team
everybody.
like makes playoffs or something. Because the Cowboys didn't do me justice last year. Last semester.
I think I might get fired if I did that.
so it was really
What?
One second.
If Jaden like approves, we just kind of like,
Just ask Jaden, just be like, are you going to let her know or shall I? Okay. I am the wrong person to be asking.
I know, like, it's fine. I just don't know, I don't like texting, like, to think people like do different things, because I feel like they'll be like, well, so-and-so already told me. Okay,
I'd annoy them, but that's me. I'm not a
great, I
great
gotta
person.
go volunteer at home so much. Thanks, Dr. Carroll.
Thank you. Thanks for coming.
I swear I have all these questions. And then I forget any of it. Are there conceptual questions on these?
I mean, I'm not gonna tell you what's on the exam, but don't I always put them on the exam? I think I always have to. It's always two or three.
Well, it was in physics one. I don't know about physics two.
Oh. That's my MO. I generally put them on. I don't guarantee it, but I generally put them on. I should do a test with only conceptual questions.
Yes.
As long as you get a bonus point for the next one.
That'd be questions like, if I lower the battery down in the water.
Yes, please.
What does it displace?
Because I wouldn't have to learn algebra, and that would
It's
really
weight.
make me happy.
It's weight, yeah. It's weight.
You can do this one. A ceramic cup has the weight of 8 newtons in air, but 6 newtons when submerged in water. What is the density of the cup?
So,
I thought it was 6 over 8 minus 6.
it should be. But that's the density of the cup relative to divided by the density of the water. So it'd be we call it specific gravity. It's the ratio of the density of the cup to the water. Is the ratio of the weight out over the weight out minus the weight in.
That should be it.
Yeah.
So
Does it
the
not match an
should be
answer?
3, right?
Say again.
Should be 3.
6 over 8 minus 6. That sounds right.
Yeah.
Is that not the answer?
It's 4. There's 3 of them.
Could be an error on my part. On the quiz. But yeah, it's out over out minus in.
I think when we find error in your file section, you should get bonus points. All day.
Sorry. That's all I can say.
We would be living it.
You wouldn't have to apologize if you gave us both. Like my chem professors is like put it in like super tiny print on the exam that if you filled out your name on both like pages of the exam, he'd give you +2 to see if you were like paying attention.
That's awesome.
I was like, idea, you never know. If I like write a physics joke on there and it's really good and it makes you laugh.
Oh, I've seen it all. Trust me. I've seen money taped to exams.
Really?
Yeah. You think I'm that cheap? It's like $3 take the test. I need it.
Oh my god.
No, I wouldn't put $3. I'd put a like substantial amount if I'm asking for an A.
I'll do anything for more than 7. Not gonna risk my
That's lunch money.
risk my career for less than my life. Crazy. All right, you guys got anything else, or can I sneak out of here?
Can we do one,
Yeah.
just, I kind of understood it when we were going over in class, but just to be sure. Using the top side approaching, bottom side receding,
Yeah,
like formula.
so we'll pick out a problem here. There's gotta be a problem there.
Let's do.
So, frequency observed, you got frequency of source, velocity of wave.
It kind of sucks
Velocity minus
because
velocity
the
of-
only examples I have were big chain problems.
Yeah.
Because zombie apocalypse problems. Because it says, what is the velocity of the observer? Your speed is now 0.25 meters per second. But
I want my notes.
the zombie is chasing after you at 0.5 meters per second while moaning at a frequency of 80 hertz.
Go on.
You carry your friend, you're running at 0.75 meters per second. What's the velocity of the source?
What's something's missing there, because you just gave me the velocity of the source. Oh,
It's
that's
a
because there's a
chain
series of
problem.
questions. Okay, yeah. So the velocity of the source was it 0.5 or 0.25? You read it to me right at the beginning.
0.5.
Okay. And then, so the velocity of source is this guy, right? And then what's the next question to ask you? What's the
What
velocity of observer?
frequency do you hear the moaning is less than 80 hertz?
So is it going to be less than or more than?
Less
Less than, right? Because you're
Yeah.
running faster away than he's running towards you. And so it's going to be less than, so F observed is less than 80 hertz. Right?
Yeah.
So how would we calculate that for this? If I wanted to calculate F observed, right? What goes in for this guy?
0.5.
80.
Oh, 80.
80, right? What goes in for this guy? Plus or minus?
It's turning away, so it'd be receding is minus.
It's receding, it's minus, right? So top side is approaching, bottom side is receding, so minus, and what is it?
0.75.
Minus or plus?
Minus.
Minus, because he's approaching me, he's running after me, right? 0.5 meters per second. Jack, does that work for you?
Yeah.
All right, I'm gonna call it a night. I've got another meeting.